With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. In this question, what they have said is enol content is maximum in. Okay. So here we have to talk about the enol content. So if you are talking about the enol content, so generally what we see over here, we have to consider the acidity of the proton, which is at the alpha position of the carbonyl. So let's say if we are talking about the option number D, then what we can observe over here is this is CH3, C double bond O. Let's say I am abstracting this proton, okay, which is at the alpha position of the carbonyl. What is the alpha position? So the carbon which is attached to sp2 carbon is said to be what? Alpha carbon. So this particular carbonyl is what? sp2 hybridized. So this proton is what? This is the sp3 carbon proton, which is what? Your alpha hydrogen. So here we have to abstract this alpha hydrogen. So when you abstract this alpha hydrogen, then the negative charge will be formed over here. So what you can see over here is whenever you are forming the enol, then what you can observe, first we have to remove the proton from alpha position of the carbonyl, and when we are removing the proton, then the negative charge is formed over here. So this negative charge, if the stability of this negative charge is more, then the enol content is going to be maximum, because for the enol formation, the first step is what? Removal of H plus. So the faster will be the removal of H plus ion, faster is going to be the formation of enol content. Okay. So if you talk about in option number 1, so there is actually 2 alpha carbons. If you see this is also the alpha carbon, this is also the alpha carbon, and this is also the what? Alpha carbon. But we have to see the acidity of the proton. So among these alpha carbon, this particular proton, if you remove from proton here, then negative charge form will be over here. So what you can observe here is this negative charge is resonance stabilized over these 2 carbonyls. Okay. So what we can observe, these negative charge is going into resonance with the two carbonyl group. Similarly over here also, if you remove the proton from here, then the negative charge form will be over here. So this negative charge is again going to the resonance to the 2 carbonyl atom. But what is the other factor that is that we have to consider to decide the enol content? That is the where this negative charge delocalization is more. So that is more in option number A rather than the option number B. Why in option 2 the delocalization is very less? Because here the lone pair of nitrogen is also involved in the resonance. So which is going to hinder the delocalization of the negative charge of the alpha carbon proton, which we have removed, and the negative charge form. So this is not is much in conjugation as compared to option number A. Why? Because these CH3 groups are showing plus I effect. Okay. And plus I effect is what? Weaker effect than the resonance. Okay. That's why the acidity of proton, which is in option number 1, is more. Similarly over here also, this lone pair is what? Getting involved in the conjugation, due to which the stability of this negative charge will be less. So but what about the option number 4? So if we are going to form the negative charge over here, so what you can observe, see, all these positions are the equivalent. So from any of the position you can remove one H plus ion and the negative charge will be formed over there. So according to this, what we can observe in option number 4, that the negative charge formed in the option number 4, that is only delocalized over the one carbon, right? So only one carbonyl group is stabilizing this negative charge. But in option number 1, 2, and 3, what we can see over there, the 2 carbonyls are stabilizing the stability of the negative charge. But that is more in case of 1, because in the other cases, the delocalization is hindered by the plus M effect of the NH2 and the plus M effect of the OCH2. Okay. So that's why here the enol content is going to be maximum for the option number 1. Okay. So let's say we'll draw the complete enol formation over here. So these H plus will remove, and this negative charge will be in the conjugation. So in this way, what is going to be formed over here, that will be O minus, here double bond CH2, and the H plus ion will be abstracted by these negative charge, and the formation of enol will be something like this: C double bond CH2, and the other end there will be one OH, and this is what? CH3. So why we are calling it to be enol? Because the all is stand for the functional group, which is OH over here there. So due to these OH, we are calling it to be all, and the this alkene part is responsible for the ene part. So combining these ene and all, we have set these compound to be enol. Okay, so all about the enol content is maximum going to be in option number 1. So our correct answer is going to be option number 1. Okay, because in the option number 1, the acidity of the proton was more, and why the acidity was more? Because when we are removing H plus, then the negative charge is dispersed over the 2 carbonyls, and due to stronger resonance, that is more acidic in compared to 2 and 3. Okay, so in this particular manner, whenever you have to decide the enol content, always what you should check the acidity of the proton. Okay, so I hope this answer your question. So correct answer is going to be your option number 1. I hope this answer your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.